High availability. Hello everyone, and a very warm welcome to our series on planning and administering Microsoft Azure for SAP workloads. In this video, we continue to explore the compute aspect of SAP on Azure. Our focus would be on high availability options which are available to make your SAP environment more resilient to failures. Now, high availability is not a new concept. It has been there for long. It simply means the ability of a system to remain operational for a specified period of time, even if the components of the system fail. Now, why is HA so important in SAP? Well, since we are running an enterprise operation on SAP, if one or more modules fail, it would mean that the whole enterprise grinds to a halt. And if the whole enterprise grinds to a halt, it would mean a loss of business, which we definitely want to avoid. Okay, now we understood what and why. Let us understand how we can achieve high availability with SAP systems on IaaS VM in Azure. Say you have a data center. Now, as you know, a data center has several racks inside it. You are using a virtualization software on the racks, and that virtualization software is going to help you create virtual machines on top of the virtualization software. Let's say this virtualization software, in this case in Azure, is Hyper-V. Now these VMs are running critical workloads and you do not want them to go down. Now consider this scenario. Albert, our IT guy, wants to perform an update on the racks, since racks, as I said earlier, have Hyper-V, and Hyper-V is an operating system. An operating system needs to be patched. Now patching often requires a restart. What will happen to these VMs? Next, consider there's a power failure in the main power source of the data center. What would happen to the VMs again? They will go down, right? In order to avoid this scenario, we try to place the VMs in a different rack, which should have a different power source and which should not be updated at the same time or the day. The problem in Azure, which is a Microsoft managed data center, is we cannot control where we place our virtual machines. This is where availability set comes into picture. So when you create two or more virtual machines, if you define an availability set, it will place two virtual machines in different racks. Now these two different racks will have a separate power source, also known as fault domain, and a separately updated rack, which is an update domain. What that essentially means is, even if one of the racks, which has your one virtual machine, goes down, the other rack will still be up. It will have a separate power source, so it will still be up if there is a fault. And these two racks will never be updated together. So Albert is going to plan that he is going to update rack 1 on a specific day and rack 2 on another day. Let's head over to the portal and have a quick demo of how this works. So let's quickly have a look how we can create an availability set. So let us create a resource group first. Click on create and let's name it AZ-120 and location, let us give us UK South, and it is created. Now we have our resource group ready. Let's go ahead and create a virtual machine here. Go to the marketplace, type in virtual machine, and we should get the virtual machine option. Let's give it a name, demo VM01, and the availability option this time we are going to select availability set. Now there is no availability set available, so we'll create a new one. Let's give it AZ or AD VM AS01. Now notice the fault domains by default is 2 and update domains is 5, which means subsequently when you put any virtual machines in this availability set, they are going to get distributed between 2 fault domains and 5 update domains. So let's click OK. Let's select Windows Server 2019 Data Center Edition. Give a username, give a password, and repeat the password. That's good. Let all defaults be there, and let's click on disks. Now notice it's premium SSD. Let's select standard SSD. We'll create the networking part. So by default, since there is no virtual network already available, the VM is asking us to create a VNet and a subnet. So it has automatically picked up a name, demo VM VNet1, demo VM01 VNet, and a default subnet. So, and it has also picked up a public IP, since we would want to log into the VM, and we need a public IP for that. Now, in a production environment, it's not recommended, but since this is a demo environment, so this is fine. Let's click on Next Management. And we don't have to change anything here. Monitoring, we will disable the boot diagnostics, because if you don't necessarily want storage account, this is just a lab environment. Click on Next and Next, and let it validate. There is a failure in the validation. So the validation has passed, and we will click on Create. While it is creating this VM, we can check the status in deployments, deployment in progress. So as you can see, it has deployed the AV set, it has deployed VM IP, it is deploying the VNet. Now, since it has deployed the availability set, we'll wait for it to deploy the VNet. The VNet is deployed. We can go ahead and create our next VM. So we will create demo VM02. Let's select virtual machine, click on Create, and let's give this demo VM02. Now here we'll select availability set, and it should give us an option. Yes, see, it's giving us as an option to select the already available availability set, which is AV set 1. Rest of the things being default, let us give a username and a password. Good. Disk, standard SSD. Go ahead and look at the properties of this VM, which is already created. We can see that it is created in this resource group, AZ-120 ADRG. This is the SKU size of the VM. Let's click on network settings, and we will see that it has a public IP. This is the public IP of the VM, and it has got a private IP as well. So the private IP comes in from the VNet on which this VM is configured. Great. Now let us go ahead and see the availability set. Availability zones. Now let us consider another scenario. The same data center and the same IT guy, Albert. Now, what if there is a flood in this area and the whole data center goes down underwater? Well, we need to keep our VMs in another data center which is nearby, but we don't know as to where the VMs should go, right? Or which is the data center which is unaffected by flood. Don't sweat. Microsoft will take care of that. You just need to define the availability zones during creation of the VM, and it will place your VM in another data center. Now you will not be able to combine availability sets and availability zones together, which means you can place your VMs either in an availability set or in an availability zone. Let's quickly head over to the portal and perform a quick demo of this. Okay, now let's create another virtual machine, and this time we are going to give it another name. And the important thing to note is we are going to select the zone in this particular example. The rest of the settings are the same. We'll give a username, password, and select the disk type, select networking, should be the same network, disable boot diagnostics and create. Let's create another virtual machine, give it a name, and this time we're going to select zone 2. Give it a username, password, and same settings, no public IP, and disable boot diagnostics and create. Now we have created two virtual machines, one in zone 1, another in zone 2. Let's talk about data disks. Now, what are data disks? If you have a virtual machine and you are running say a database on it, right? You will have a OS drive, as well as you will have another drive which is called a data disk, on which you will actually place your data. Now you need to make sure that these data disks are redundant. They are saved in case of any failure. So like VMs, disks also have redundancy. Since there is an important data on these disks, Azure Managed Disk provides redundancy by default. Now by default, the managed disks are replicated 3 times. In case you want locally redundant storage, the data disks are replicated 3 times within the data center. Whereas if you select a zone redundant disk, the data disks are replicated across the data centers. You can select ZRS, zone redundant disks, where the disks are replicated across the data center. So Microsoft has built redundancy at the infrastructure level for us, which we can benefit from. But you may ask, okay, fine. Now what about the operating system itself? Now Microsoft cannot control the operating system. That is something which is on us because we are using a infrastructure as a service, IaaS. So what happens if the operating system crashes? Now, before we look into that, let's head over to the portal and quickly perform, look into the portal. What are the ZRS and the LRS settings? And then we will come back to the OS question. Let's head over to the portal and let us go to our data disks. Now, in order to perform this exercise, you have to shut down the VM. Just give it a name, and then you can see that you have zone redundant disks available. Now you can select that and save the disk. Now let's try to understand how to avail high availability on OS layer. So we will be covering Linux and Windows OS mainly. Let's say you want to set up a HANA database. Now what does HANA database mean? HANA database is SAP's own database system. HANA stands for High Performance Analytic Appliance. Now SAP HANA primary node is replicating data to the secondary node, and they are in a failover cluster. This is to ensure that no data is lost during the failover. Both the database are running at the same time. However, only one database is supporting the customer workloads. In case the primary server fails, Pacemaker cluster can detect it and shut down the primary database and activate the secondary database. Now, since there is a synchronous replication between the primary and secondary database, there should not be any data loss. In HANA, being an in-memory database, the data is preloaded into the RAM, and that is the reason why the failover is very fast. Now, the primary and the secondary servers communicate over the network using something called CoroSync. Nodes communicate to each other on health status, and they tell each other how each of the VMs are performing. Let's consider 2 scenarios. Primary server is frozen, or the primary server is healthy, but the network communication is not happening or is not reachable. In the first scenario, the failover should happen to the secondary server. However, in the second scenario, failover could be prevented since both the servers would be active, and it would be a scenario where both the servers are primary. So this kind of scenario is called a split brain. So this situation is extremely dangerous and should be prevented, since some of the business transactions would be written on the primary as well as on the secondary servers. To prevent this, Pacemaker uses a fencing mechanism called Stoneth. Now what does Stoneth stand for? Shoot the other node in the head. Yeah, it sounds a bit funny, but that's what it is called. What this essentially does is, in case the nodes do not communicate, or the nodes cannot communicate, it will kill the other node to ensure both the nodes are not active at the same time. The surviving node will serve the customer workloads. There are various ways to achieve fencing. However, in Azure, we use something called as Azure Fencing Agent. We have a load balancer in front of the servers, which will take care of balancing the load to the required server. Now, this load balancer is not going to distribute the load across these two servers, but what it is essentially going to do is, if it gets a response from the primary server, it's going to send the traffic to the primary server, and in case Tonith comes and kills that node, it is going to send the traffic to the secondary server. So for the applications, the database IP would be the same. It will be the VIP, the virtual IP of the load balancer. So essentially what we are doing is, in the background, we are creating a highly available environment. Now let's look at the same scenario, but in a Windows environment. In Windows, it's called a Windows Failover cluster. Here, we create two virtual machines in an availability set. Now we deploy a Windows Failover cluster. Next, we deploy a load balancer so that one of the servers can serve the customer workload. Cluster Resource Manager communicates within the nodes and ensures that the nodes are healthy. However, the Cluster Resource Manager cannot take a decision whether a node should be allowed to continue in the cluster. Since similar to the earlier example, we may encounter a split brain here as well. This is where quorum comes into picture. In order to set up a quorum, we need to set up a cloud witness. The cloud witness can be a storage account, file share, or a shared disk. However, in this example, let us consider cloud witness is a file share. Each of the cluster resources and the file share has one vote. In case one of the servers is frozen or unable to communicate out to the other nodes, a vote will be cast, and if the votes are less than 3, in this case, whilst the server which is unable to communicate is unable to vote, the cluster manager will stop the node, and hence there will be only one primary server, so the data doesn't get written on both the nodes simultaneously. So we saw how we can achieve HA on the OS level as well. Let's look at other compute features. Now let us look at other compute aspects. Azure offers various VM sizes and types, and each have a different mix of performance capabilities. One of the capabilities is network throughput. Larger machines are allocated more bandwidth, and smaller machines are having a lesser bandwidth. Network bandwidth allocated to each virtual machine is measured in outbound, also called egress traffic from the virtual machine. This means the traffic into the VM is not measured or limited, only the outbound traffic is limited. Let me also introduce you to another concept called accelerated networking. Now you can implement this feature into a VM, which will improve the network performance, throughput, and latency of the VM. The network interface will be in a super performance mode. However, the acceleration will be limited by the egress limit of the virtual machine. However, we should note the fact that there are some factors which do not affect the network egress of a VM. Number of network interfaces, traffic destinations, and protocol. These three factors will not affect the network egress of a virtual machine. We should keep these points in mind, since you might get a question in the exam which is related to this. Now, apart from network bandwidth allocated to each virtual machine, there is another pressing factor which might impact the network performance of an Azure VM. It's called a network flow. Now, what is a network flow? Azure networking stack maintains the state of each direction of TCP, UDP connections in a data structure called flow. A typical flow is distinguished by 5 tuples. Those are protocol, local IP address, remote IP address, local port, and remote port. The data transfer between the endpoints requires creation of several flows in addition to the flows that perform data transfer. For example, DNS resolution creates a flow, load balancers which send health probes back to the VM create a flow. Now there is a limit to the number of flows typically a VM can handle, 500,000 active flows in one direction. Now what happens if the flow limit is hit? And once this limit is hit, the other connections are dropped. This is an important consideration when you are planning for a VM for SAP workloads. Lastly, there's a question of sizing. How do we ensure that our SAP workload, when run in Azure, gets a proper sizing as per expectation? Because sizing is directly proportional to the performance of the VM. There are certain considerations which you should be accounted for when you're sizing a Azure VM. The first consideration is SAPs. What is SAPs? SAPs is simply, application performance standard, which helps somewhat describe the performance of the system configuration in an SAP environment. The next consideration is hyperthreading. Hyperthreading essentially means each logical core of a CPU can have 2 logical threads. Now, SAP applications may or may not support hyperthreading, hence it would be beneficial to check the SAP note provided in the description and also test the setup beforehand, that whether you are getting the benefit of the hyperthreading or not. Also, it might be beneficial to check the correlation of the VM size and the maximum network bandwidth which is accommodated by the VM. Just before a few slides we saw about the network flows. So you should know what is the bandwidth limit of your virtual machine. Now, there are some tools which can be utilized to perform sizing. SAP Quick Sizer helps determine the appropriate SAPs for running an application. A more rudimentary way would be to use reference-based sizing. In case you have already existing setup, you can refer to the size, what is the size of the already existing setup, CPU, RAM, storage. And lastly, t-shirt based sizing, wherein you increase or decrease the size based on the performance parameters. So it is more of a hit and trial. So you create an environment, you put in SAP certified virtual machines there, you size them as per your understanding, and later based on the performance, if you are getting high performance, reduce the size of the VMs. If you are getting low performance, increase the size of the VMs so that you get optimal performance at optimal cost. That brings us to the end of this video. We learned about high availability concepts and some abilities of Azure VMs. We also looked into the sizing considerations of the VMs in this video. Small quote: it is important to have a great attitude towards your studies. Taking breaks, having an organized workspace, rewarding yourself from time to time helps you stay productive and gain confidence. Well friends, thank you for watching this video, and if you find it useful, please consider sharing, commenting and subscribing to my video. Let me know how I am doing. It will help me motivate and improve my videos more. Thank you for watching, and I'll see you in the next one.